Thank you, Sarah. Pretty weird story, I guess, but whatever. Okay, so hi guys and girls. I'm Sven. I used to work in the Babel core team. I participated in TC59, Webpack, and a bunch of REST and WebAssembly stuff. That's basically it. And as Sarah mentioned, I started working at Cloudflare 2 weeks ago. Cool. So this is a talk about WebAssembly. So you might be wondering what is wrong about JavaScript, right? So when you used to work on a big application, the cold start of your application might be an issue at some point. Because when you use like a React app or something, it needs to get these text documents, download them, actually parse them to get meaningful JavaScript out of it. Then the engine starts compiling it, re-optimizing it, etc., etc. This can be quite slow in some cases. So this can be a big deal with big applications. Also, as you probably know, JavaScript is pretty dynamic, completely untyped, and has a complex runtime. For instance, it has a lot of rules in the runtime to actually figure out which type you pass in which functions. So this can take some time. And eventually, JavaScript became a compilation target, because if you think about the web, the only way to run any sort of code in the web is JavaScript, right? So people that wanted to use a new language or their favorite language, which isn't JavaScript, they couldn't do it. They will be forced to compile down to JavaScript. And in fact, JavaScript was never designed for that, because as I mentioned, it's super dynamic and so on. So here we go. We have a couple of languages that compiles down to JavaScript to target the web. Pretty obvious. So since this is a WebAssembly talk, I guess WebAssembly can help us in some way. So this is the same diagram where WebAssembly comes in place. So you have different languages like C, C++, Golang, Haskell, and so on. And you have these compilers. All these compilers are compiling down this language to WebAssembly. Okay? Does it make sense? And so one thing that is missing is that, what are we doing with this WebAssembly module now? WebAssembly is actually designed to be in some sort of portable format. So you can actually target your favorite web browser, but you can also target any other environment that supports WebAssembly. If you saw the Mozilla WASI announcement a couple of days ago, it's actually a way to target like native environments with WebAssembly. So that's pretty cool. Okay, so I'm talking about this thing, but what's WebAssembly really? So if you go on the website, they say that WebAssembly is a portable, low-level, safe format. So you already saw the portable and the low-level part of it, because it's obviously a compilation target, so it must be low-level. The safe is more that the inside of the module is safe in some type-checking sense. Anyway. And so you can see WebAssembly as a black box. You can't really know what's inside because it's just compiled code. We don't really know what it's doing. But what you know is that WebAssembly has two important sections for you: the import section and the export section. These actually specify the interface of the module. In the import section, you can import any JavaScript function, any JavaScript value. In the import section, you can export any WebAssembly value or any WebAssembly function. That you will be able to call it in JavaScript, or you will be able to call a JavaScript function in WebAssembly. Okay? And so I saw Nick's talk. I don't know if Nick is in the audience. So here's my take on unpopular opinions, whatever this means. I hope you can read it. So a common question I get is that will WebAssembly eventually kill JavaScript in some way? Or will we replace WebAssembly we will replace our JavaScript code with WebAssembly? And my answer is no. You probably won't. JavaScript is a cool language. We are all here for JavaScript, right? Not for Finnish food. Sorry, Yoro. And JavaScript is, if you use JavaScript daily, keep using it, that's fine. WebAssembly is all about enabling new languages on the web. Quick question. Who of you uses a non-JavaScript language, and probably not TypeScript, but who uses Rust, for instance? Okay, a couple. Who uses TypeScript? Nice. So actually, Rust and many other languages, but also TypeScript, can compile down to WebAssembly currently, which is pretty cool. And so, should we WebAssembly all the things? Why couldn't you just take your JavaScript project and compile it down to WebAssembly? There's some pain point currently. WebAssembly only allows you to exchange numeric types at the boundary, which means that you cannot import a high-level JavaScript object. And this kind of a restriction actually, currently, I mean. But we are working on this, and this is going to be much more JavaScript friendly at some point. So my answer is probably not, but that's fine. And if you go on the WebAssembly website, it says that it has been designed to be a complement, and of course not a replacement of JavaScript. So imagine in your application, you have your JavaScript, which does, I don't know, a fetch request or something. And then you have your WebAssembly module written in Rust, which does the, I don't know, an image decoding of your fetch request, something like that. The goal of WebAssembly is really to integrate a WebAssembly module written in some language with your JavaScript application. That's really cool. And I actually have a demo. Cool. So I have here a small JavaScript project where I used Webpack, Babel, etc. So it's just a React application where I have a component which is my app. And my app is actually, I made this app just for fun, is actually to pass a NI calendar format. So if you are going to meetups, they send you emails with a .ics file format. And so you can easily decode it. It's really easy. You just take each line of the file and you can extract the location. You can also extract the time of the thing. So that's really straightforward. And I'm going to run it. Oh, I can zoom in. Oh, that's too much. Okay, so this is my cool application. And it actually just passes the calendar invite and tells me the date and the location. That's pretty easy. So let me tell you something more. So there is one organization on GitHub and one branch in the Rust project, which is called Rust in WebAssembly Working Group. This Rust WebAssembly, yeah, you got it, is made to actually let WebAssembly, or WASM in this case, talk to JavaScript more easily, which means that you must be able to pass a Rust structure into JavaScript and manipulate the Rust structure in JavaScript. It's doing some JavaScript on the hood, because currently it's not really possible in WebAssembly itself. So my project is using this template. You can just go on GitHub and clone it and actually run it. So it's pretty easy. So going back to my demo. So what I want to do now is that I don't like JavaScript, so I want to write this in Rust, right? So in the template, you have a create directory where you have your Rust source. And in this Rust source, you can go into the main file where you can import your Rust create, which has been compiled to WebAssembly. And you can extract, where I go? Okay, anyway. So I'm using this import I hope you are all familiar with the import function. So basically, it's the dynamic import. OK. And so if I run it into my browser, I will get the same UI. And if I try to parse my file, the parse function is not here yet. Because as I mentioned before, the WebAssembly module is like a black box. You don't see what's inside. And actually, there's pretty much nothing inside. This is the code of the module. So what I can do now is create a parse function and recompile my thing. So Webpack is going to recompile it on the fly. And now, oops. So you need to annotate your function with this wasm bindgen, so you can actually use it in JavaScript. And now I can call this function in JavaScript. That said, there's nothing inside. So one thing I can do, because I'm quite lazy, is to say, OK, I depend on something external, like the parse function here, which is defined in my iCalendar.js file. So this is actually the code that I showed you earlier. So what this is doing is that I'm taking my JavaScript function, importing it into my Rust project, and now I can just call it like this. Source. And so in that case, I can pass my calendar event. Does it make sense? Cool. And now, because this kind of sucks, I don't want to call into JavaScript. What I can do is implement my own parse function like this. Oh, it's pretty big. But anyway, it's really the same code that you saw earlier, like taking the location, taking the date. And here we go. It's still there. And if I have, I think I have some extra time still. And if you go even further, what you can do, so if you are into serverless and Cloudflare stuff, what you can do is actually take this same code and deploy it into a worker on Cloudflare. So we are going to release a tool that is going to ask Webpack to build your project and taking the whole bundle with the WebAssembly module and pushing it into a worker. So now I have my code somewhere in the cloud. And I can just pass my iCalendar event. And you can see the request going here with my cool domain name. That's pretty good. And I still have some time, I guess. OK. So just to make sure I'm not lying to you, I can just edit the output I'm doing, recompiling the stuff, deploying it into the Cloudflare worker, and going ahead and compiling my file again. And it doesn't work at first. So it's actually a reload, a hot reload that is doing. So here we go. I have my hi Sarah thing.